Good evening, students. Today I am going to explain you electric motor. We are very familiar with motor. What motor does? When we switch on motor, it will lift water from ground floor to the tank. So, from this we can conclude that motor is a device which converts electrical energy. We are switching on motor. It means we are giving electrical energy to the motor. So it is converting electrical energy into mechanical energy. So motor is a device which is converting electrical energy into mechanical energy. So motor is a device which is converting electrical energy into mechanical energy. Now, on what principle does motor works? Motor works on the principle of magnetic effects. Electric motor works on the principle of magnetic effects of electric current. It means whenever we place a current carrying wire in magnetic field, then it will affect with some magnetic force. So that is why electric motor works on the principle of magnetic effects of electric current. Now let us go into the detailed working of electric motor. How electric motor works? In any electric motor, there will be two permanent magnets. These two are permanent magnets. One magnet will be faced north pole and another magnet will be faced with south pole. So here in these two permanent magnets, there will be between these two permanent magnets, there will be strong magnetic field between these two magnets, and magnetic lines of force will be passing between these two magnets. So between these two strong magnetic field, between these two a strong magnetic field will be created and magnetic lines of force will be passing between these two magnets. And between this strong magnetic field, in this strong magnetic field, a rectangular wire will be placed. A rectangular wire will be placed. If we place set of such rectangular wires, then they are called as armature. If we place set of such rectangular wires, then it is called as armature. Now in this rectangular wire, when we pass current in this rectangular wire, then here in this rectangular current carrying wire there are four parts. This is one part, this is second part, this is third part, and this is fourth part. This is first part, this is second part, this is third part, and this is fourth one. So here first, if you observe this wire and this wire, if you observe these two wires are parallel to the magnetic field. These two wires are parallel to the magnetic lines of force. These two wires are parallel to the magnetic lines of force. It means these two wires are parallel to the magnetic field, and when current carrying wire is placed parallel to the magnetic field, then force acting in it will be zero. When current carrying wire is placed parallel to the magnetic field, then force acting in these wires will be zero. Force in these two wires is zero. Now we have this wire and this wire. We have another two wires. Now these two wires are placed perpendicular to the magnetic field. These two wires are placed perpendicular to the magnetic field. Whenever a current carrying wire is placed perpendicular to the magnetic field, remember these two wires, this wire and this wire. Whenever a current carrying wire is placed perpendicular to the magnetic field, then force acting on it is F is equal to BIL. F is equal to BIL is the magnetic force acting on a wire placed perpendicular to the magnetic field. So here on this wire and on this wire, same amount of force will act. F is equal to BIL. F is equal to BIL. But according to Fleming's right hand rule, force acting on this wire will be downwards and force acting on this wire will be upwards. So according to Fleming's right hand rule, force acting on this wire is downwards and force acting on this wire is upwards, but the force value is same. F is equal to BIL. These two equal and opposite forces will form a torque. These two equal and opposite forces will form torque, and they will rotate this current carrying wire. Hence, whenever we pass current, this current carrying wire will be rotated. It means here electrical energy, we are supplying current, it means we are supplying electrical energy. This electrical energy will be converted into rotational energy. So electrical energy is converted into rotational energy, and rotational energy is nothing but a form of mechanical energy. Here we have, so here we have some important points, that is here we have one more important point, that is why we are going to use these rings here. These rings are called split rings. Why we are going to use these two split rings here? Let us see why we are going to use those two split rings. So here these are called split rings. This is very important point in this electric motor. These two are split rings. These are split rings. Why we are going to use these split rings? So split rings, they are also called as, it is also called as commutator. Split rings also called as commutator. Split rings also called as commutator. Commutator. So split rings are used to reverse the direction of the current for every half revolution. Split rings are used to reverse the direction of the current for every half revolution, and split rings are always used in DC current only. Split rings are always used in case of DC current, that is in case of DC motor or DC generator. Split rings are always used in case of DC motor or DC generator. They are always used in case of DC current only. And split rings will be always in semicircular shape. They will be like semicircular shape. And I request you, do not get confused with slip rings. These are slip rings. Slip rings will be slip rings. Slip rings will be in circular shape. Do not get confused with slip rings. Slip rings will be used in, always they will be used in AC generator or AC motor or AC current. Remember, slip rings are always used in case of AC, whereas split means semicircular rings will be always used in case of DC, and slip means circular rings are always used in case of AC current. Whereas split rings have a specific purpose. Split rings are always used to reverse the direction of the current for every half revolution. Split rings, they have a specific purpose. They are always used to reverse the direction of the current for every half revolution, whereas slip rings do not have any specific purpose. They are just used to maintain the contact with rectangular coil. They are just used to maintain the contact with rectangular coil. They are used to maintain the contact with rectangular coil. Yes, I hope it's clear. Thank you everyone.